This is the EdExcel GCSE 9-1 Maths Paper 3 from the higher tier, and it's from the June 2022 series. Question number 1. Here is a right-angled triangle. We've got 4 centimeters, 8.5 centimeters, and x centimeters. We have to work out the value of x. Well, to do this question, we can use Pythagoras' theorem. We have x squared plus 4 squared equals 8.5 squared. The sum of the squares of the two shorter sides is equal to the square of the hypotenuse. And so, we have x squared plus 16 equals 8.5 squared, which is 72.25. And if I subtract 16 from both sides, we have x squared, which is equal to 56.25, and therefore square rooting to find out what x is, it turns out x is equal to 7.5. And so x is 7.5. Question number 2. We have t equals 4m squared subtract 11. We have to work out the value of t when m is equal to -3. We replace the m with -3. And so we have t equals 4 multiplied by -3 squared minus 11. Now, what we can do is substitute -3 into our calculator to work this out. We have 4 multiplied by -3 squared, subtract 11, which is 25. So we have 25 for t. And then for part B, we have to make p the subject of the formula d equals 3p plus 4. So we want to get p by itself. So far we have d equals 3p plus 4. If I subtract 4 from both sides, that would mean 3p equals d minus 4, and therefore p will equal d minus 4 divided by 3. So we have p equals d minus 4 over 3. Question number 3. Rick, Selma and Tony are playing a game with counters. Rick has some counters, Selma has twice as many counters as Rick, Tony has 6 counters less than Selma. In total they have 54 counters. The number of counters Rick has to the number of counters Tony has is 1 to p. We have to work out the value of p. First of all, let x equal the number of counters Rick has. And if that's the case, then Selma would have twice as many as Rick. So Selma has 2x counters, and Tony has 2x minus 6 less than Selma. And in total, they have 54 counters. And so therefore, we have x plus 2x plus 2x minus 6 equals 54. So, simplifying, we have 5x minus 6 equals 54 5x is 60, which means x is equal to 12. So that means Rick has 12 counters, Selma would have twice this, which is 24 counters, and Tony would have 6 less than this, which is 18. And therefore, the ratio Rick to Tony, that will be 12 to 18. And we need to write this in the form 1 to p. So for me to write this in the form 1 to p, well, I need to divide both sides by 12. And so 18 divided by 12, that's 1.5. So we have 1 to 1.5. And therefore, the value of p is 1.5. Question number 4. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of rolls of wallpaper from each of 2 shops. With Chick Decor, we've got 3 rolls for £36, and for Style Papers, pack of 5 rolls, normal price is £70, and we have 12% off the normal price. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chick Decor or from Style Papers? You must show how you get your answer. Let's consider Chick Decor. We have 3 rolls, which would cost £36. To find out the cost of 15 rolls, we would have to multiply by 5. 36 times 5 is 180. So 15 rolls would cost £180. Now, if we consider Style Papers, then we have a pack of 5 rolls. The normal price is £70, and we have 12% off the normal price. So that means that the cost here for 5 rolls that would be, well, if the normal price is £70 and we get 12% off, we multiply 70 by 0.88. So that will be £61.60. And so, for 15 rolls, we would have to multiply by 3. And it turns out we get £184.80. So that's how much it would cost from Style Papers. And just to reiterate, this value came from multiplying 70 by 0.88. Now, which one's cheaper? Well, clearly, Chick Decor is cheaper. And so we would have to buy from Chick Decor. Question number 5. The table gives information about the length in centimeters of some pieces of string. So we've got the length and the frequency. Amos draws a frequency polygon for this information in the table, and we have to write down 2 mistakes. Well, if we take a look on the frequency polygon, well, what we're supposed to do is plot the midpoints against the frequencies. So the midpoint here is 5, then here it's 15, here it's 25, here it's 35, and here it's 45. So let's check those points. We've got 5 and 15, that's fine. Then we've got 15 and 20, that's fine. Then we've got 25 and 50, so 25 and 50, that's here. And then we've got 35 and 25, so 35 is here, 25 is here. And then we've got 45, 5, well that's being plotted at 55. So an incorrect point 55 is mapped. And if we take a look at the scale, we've got 0, 10, 20, 30, but 40 is missing. So 40 has been missed from the frequency scale. Question number 6. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. We have to work out Amy's average speed in miles per hour. First of all, you will find that here we've got miles per hour for the units, and here we've got minutes. So we need to make the units consistent. We can convert the minutes into hours, and to do this we can divide by 60. Hours to minutes, we times by 60. So if we consider the first part of the journey, we can find the distance. And we can also do the same thing for the second part of the journey. So the total distance, that's equal to, well, she runs for 15 minutes. So we have 15 divided by 60 multiplied by 6. And if I work this out, we get a quarter of 6, which is 1.5 miles. And then we've also got the 40 minutes that we divide this by 60 and then times by 9. So I've got 1.5 plus 6, which is 7.5 miles. So it takes Amy 45 minutes to run this distance. So what we need to do is convert this 45 minutes into hours by dividing it by 60. So her average speed, that's equal to the total distance, 7.5 miles. And then I need to divide this by 45 over 60 hours. So I have 7.5 divided by 45 over 60, which is 10 miles per hour. Question number 7. The diagram shows rectangle STUV T, QU and SRV are straight lines, all measurements are in centimetres. The area of the trapezium, QUVR, is a centimetre squared, and we have to show that A equals 2x squared plus 20x. Well, what we need to do is find out the length of the trapezium. Here we have a total length of 3x plus 5, and we are subtracting from that 2x. So that means what we are left with is 1x plus 5. So here we have x plus 5. X plus 5 plus 2x is 3x plus 5. Opposite sides of a rectangle are equal. We also have the height of the rectangle, which will be 4x. And so what we can do is find out the area of the trapezium. The area A equals 1/2 multiplied by the sum of the two parallel sides. So we have 5 plus x plus 5 multiplied by the height, 4x. So a half of 4x is 2x, and then inside the bracket we have x plus 10. And if I multiply the 2x into the bracket, we end up with 2x squared plus 20x. Question number 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of the electricity he has used. And for part A, we have to work out the gradient of the straight line. Well, the gradient will equal the change in y over the change in x. So here, for the gradient, the change in y, well, here is the change in y. We need to find out what this point here is. This point is 140 is 19.6. So if I find out the change in y, that will be 19.6 take away 0, and the change in x will be 140. So if I work out what this is, 19.6 divided by 140 is 0.14. So the gradient is 0.14. And then for part B, what does the gradient of the line represent? Well, here we've got cost against number of units used, and so the gradient would represent the cost per unit of electricity. Question number 9. For part A, we have to express the square root of 10 to the 360 over 10 to the 150 times 10 to the 90 as a power of 10. Well, what we can do first of all is recognize that we have the same bases under the square root. Now, when we square root something, that's the same as raising something to the power of 1/2. So we have 10 to the 360 divided by 10 to the 150 times 10 to the 90, all raised to the 1/2. And so what we can do here then is recognize that on the bottom we have the same base and we are multiplying, so we can add the powers. So if I add the powers, we have 10 to the 150 plus 90 on the bottom, and on the top we've still got 10 to the 360. And I'm raising this to the 1/2. So on the top I've got 10 to the 360, and on the bottom I have 10 to the 240, and this is being raised to the power of 1/2. So when we have the same base and we are dividing, we subtract the powers. So we have 10 to the 360 subtract 240 raised to the 1/2. So we have 10 to the 120 raised to the 1/2, and at this point we can multiply the powers. So I have 10 to the power of 120 times 1/2, leaving me with 10 to the 60. So I have expressed the calculation as a single power of 10. We have 10 to the 60. Then for part B, Liam was asked to express 12 to the 50 to the power of 2 as a power of 12. He wrote 12 to the 50 to the 2 equals 12 to the 50 to the 2, which is 12 to the 2500. Liam's method is wrong. We have to explain why. Well, if I have a power to another power, I have to multiply the powers. So we should multiply the powers of 12 to get 50 times 2 rather than 50 to the power of 2. Question number 10. Jane bought a new car 3 years ago. At the end of the first year, the value had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. We have to work out the value of the car when Jane bought it 3 years ago. We begin this question by letting x equal the original value of the car. And if that's the case, I've got x multiplied by, now here, at the end of the first year, the value decreases by 12.5%, so that multiplier is the same as 0.875. And then it decreases by 10% for the next year, and then also 10% for the year after that. So the multiplier in that case is 0.9. And at the end of all this, we get 17,010 pounds. So to find out what x is, we've got 17,010 pounds divided by 0.875 times 0.9 times 0.9. So let's work this out. It turns out we get 24,000. So the value of the car when it's new is 24,000. Question number 11. Raheem has 16 shirts, 5 pairs of jeans and 3 jackets. Raheem chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans and 1 jacket. We have to work out how many different outfits Raheem can choose. So, to find out the number of combinations, we multiply 16 by 5 by 3. And it turns out we get 240. So there's 240 combinations. Question number 12. ABC and ACD are right-angled triangles. DC is 8 centimeters. The angle ADC is 45 degrees and the angle ABC is 20 degrees. We have to work out the length AB correct to 3 significant figures. Now for me to find out what AB is, I somehow need the length AC. And we can find out what AC is using trigonometry. We've got the adjacent, and we are finding AC, which is the opposite to the angle. What connects those is tan. So we have tan of 45 equals AC divided by 8. And so therefore, AC equals 8 multiplied by tan 45. So if I work this out, 8 times the tangent of 45, that's 8. So here we have 8 centimeters. Now if I consider the triangle ACB, I've got 8 centimeters for the opposite. AB is the hypotenuse which I'm finding. What connects those is sine. So I've got sine of 20 equals opposite 8 over the hypotenuse AB. So therefore, AB is equal to 8 over the sine of 20. So if I work out what this is, we get 23.39, etc. So to 3 significant figures, we have 23.4 centimeters. Question number 13. A and B are vectors such that A equals 2, -3 and 3A subtract 2B equals 8, -17. We have to find B as a column vector. Well, let's write out the calculation 3A subtract 2B. We have 3A subtract 2B, which is equal to 8, -17. 3A, well, I've got 3 multiplied by 2 minus 3, subtract 2B, that's equal to 8, -17. So 3 times 2 is 6, 3 times -3 is -9. I subtract from that 2B, and that's equal to 8, -17. So now let's rearrange for 2B. 2B is equal to 6, -9, subtract 8, -17. So if we work out what 2B is, 6 subtract 8 is -2, Negative 9 subtract negative 17, well, that will be positive 8. And therefore, to find out what the vector b is, I need to half this, so I get -1, 4. So that's what the vector b is. Question number 14. For part A, we have to factorise fully 4p squared subtract 36. Here we can recognise we have a difference of 2 squares. Now before we do anything else, we can hopefully recognise 4 is common to both, so inside the bracket we would have p squared subtract 9. Expanding this out, we get 4p squared minus 36. So we have 4 multiplied by p minus 3 multiplied by p plus 3. So we have factorised fully that expression. Then for part B, we have to show that m plus 4 multiplied by 2m minus 5 multiplied by 3m plus 1 can be written in the form am cubed plus bm squared plus cm plus d, where a, b and c are integers. Well, if we have m plus 4 multiplied by 2m minus 5 multiplied by 3m plus 1, I can multiply together the 2m minus 5 and the 3m plus 1. So I've got m plus 4 multiplied by, well here 2m times 3m is 6m squared. Then I've got 2m times 1 and then minus 5 times by 3m. So that's 2m minus 15m, which is minus 13m. And then I've got minus 5 times 1, which is minus 5. So now we need to multiply all of this out. M times by 6m squared, that's 6m cubed. M times by minus 13m, that's minus 13m squared. M times minus 5, that's minus 5m. 4 times by 6m squared, that's 24m squared. 4 times minus 13m, that's minus 52m. 4 times by minus 5, that's minus 20. And so if I simplify all this, I've got 6m cubed plus 11m squared minus 57m minus 20. And so here is my factorized, here is my expanded expression. Question number 15. P, Q, R and S are 4 points on a circle, that's what we see here. And P, X, R and S, X, Q are straight lines. We have to prove that triangle PQX and triangle SRX are similar. First of all, we can see that the angle PXQ, which is this one, will equal this angle here. And that's because vertically opposite angles are equal. Then we have this angle QPX equaling this angle here, and the reason for that is they are angles in the same segment. And that's because angles in the same segment are equal. And similarly, this angle here is equal to this angle here for the same reason. So the angles in the same segment are equal. Now, these triangles will be similar because the corresponding angles are equal. So all three pairs of corresponding angles are equal, which means the triangles are similar. Question number 16. P is equal to 2e over f square rooted, e is equal to 6.8 to 1 decimal place, and f is equal to 0.05 to 1 significant figure, we have to work out the upper bound for the value of p to 3 significant figures. Well, if I calculate the upper bound of e, that will equal 6.85. The lower bound of e will equal 6.75. The upper bound of f equals 0.05, and the lower bound of f, that's equal to 0.055, and the lower bound is equal to 0.045. Now what we want is the upper bound of p. So the upper bound of p, that's equal to 2 multiplied by the upper bound of e divided by the lower bound of f and then square rooted. So, working this out, we have 2 multiplied by the upper bound, 6.85, divided by the lower bound of f, which is 0.045. And then this needs to be square rooted, and working this out, we get this value here, which is 17.448, etc. Now, to 3 significant figures in, p is equal to 17.4. Question number 17. The table gives information about the distances in miles that some Year 10 students live from school. And we've got the distance and the frequency, and for part A we have to draw a histogram for this information. Before we do anything else, we can find out the class width of each of these intervals. Here we've got 1.0, here we've got 0.5, here we've got 0.5, here we've got 1.0, and here we've got 2.0. And now to find the frequency density, what we would have to do is do the frequency divided by the class width. 90 divided by 1 is 90. 48 divided by 0.5, that is equal to 96. 22 divided by 0.5, that's 44. 8 divided by 1 is 8. 12 divided by 2, that's 6. So now we need to plot the frequency densities against the class width. So let's do that. Now, what we need to do first of all is come up with a scale. We've got 1, 2, 3, 4, 5, 6 blocks, and each block can be worth 20. So here I've got 20, here I've got 40, here I've got 60, here I've got 80, here I've got 100, Here I've got 120. So now let's plot those. So the first one I've got is 90. So 90, that is in between 80 and 90, and that goes up to 100, like so, and then draw a vertical line down. And for after that we've got 96, so 92, 94, 96 is over here, and the class width for that was 0.5. So now let's draw a line down. So joining these up, we have this over here. Then for the next one, we've got 0.5 to 44. So 44, that will be over here, and then join it across horizontally, like so. Then we've got 1 and 8, so that takes us to 2.0 to 3.0, and then 8. So if I draw 8, I've got 2, 4, 6, 8 up to here, and then draw it across, and then I've got 2 and 6, so that takes me up to 5. So now draw a horizontal line across. So here is our completed frequency density histogram. Now the histogram below shows information about the distances in miles that some year 11 students live from school. So we've got the distance, and we've got the frequency density, and the number of year 11 students who live between 1 and 2 miles from school is n. And we have to find an expression in terms of n for the number of year 11 students who live between 3 and 5 miles from school. So between 1 and 2, the number of students here is n. Okay. And if I show that, here we've got n, and what we need to do is find the number of students between 3 and 5 in terms of n. So how do we get this n? Well, the area of this rectangle would give n. So the area of this rectangle is n. So if the area is n and the class width is 1, that means that if here I've got 1, the height over here will be n then. So if I consider this rectangle, I've got 1 over here and n over here, which gave me that area of n. Now this height then is split up into 3 tinier bars, which means that for each one of these we would have n over 3. So here, here and here we have this height being n over 3. So if this height is n over 3, here we would have 2n over 3, and here we have 3n over 3, which is quite simply n. So if this height here is n, what I need to do is find out what this bit is worth. So this bit then, n over 3 is being split up into 5 parts. So I've got a third n being split up into 5. So that's 1 over 15 times by 3. So that over here is worth n over 5. So each tiny little square is worth n over 15. So for this rectangle here, we have a class width of 2, a height of n over 5, which means the area then will be n over 5 times by 2. A fifth times 2 is 0.4 n. So the number of students will be given by 0.4 n. Question number 18. Here is a prism ABCD SPQR. The base ABCD of the prism is a square of side 14 centimeters. T is the point on BC such that BT to TC is 43. The cross-section of the prism is in the shape of a trapezium of area 147 centimeters squared, and CR is 12 centimeters. We have to find the size of the angle between the line ST and the base ABCD. Now, before anything else, what we can do is find out BT and TC. We can do this using this ratio 4:3. So we've got this ratio BT to TC being 4:3, and in total we have 14 centimeters. 7 parts in total. 14 divided by 7 is 2. So we have 2 for each of these boxes, which means BT is equal to 8 and TC is equal to 6. So we have 8 centimeters here and 6 centimeters here. Now, what we can do is, well, if I create a line connecting D and T together, like so, we can find out what DT is using Pythagoras, recognizing that DC is also 14 centimeters. So, DT squared is equal to 6 squared plus 14 squared, which if I work this out, we get 232. And so dt is the square root of this, which as a decimal is 15.23, etc. So here we have 15.23, etc. centimeters. And what we need to do is find out the angle between the line ST and the base. So that would refer to this angle here, which I will call theta. So this angle here is theta, and I need to find out what theta is. Now, first of all, I need to find out what SD is, and I can do that by using the information I know about the area of the trapezium. So if I use the fact that the area of the trapezium is 147 centimeters squared, well, to work out the area of the trapezium, I've got 1/2 multiplied by the sum of the two parallel sides. So I've got here SD plus the 12 here multiplied by the 14. It turns out we get 147. So now we can find out what SD is. To find out what SD is, I've got 147 divided by 7. Now that's 7 comes from 14 times 1/2. So that's 21. And if I take away 12, that's 9. So SD is equal to 9 centimeters. So I have 9 centimeters here. Now if I take a look at this triangle, I've got the opposite and the adjacent, and what connects those is tan. So tan theta is equal to the opposite, which is 9, divided by the adjacent, which is 15.23, etc. So if I work this out, I can find out what theta is. I've got the inverse if I store this into it, I've got 9 divided by this, and then I want the, so here I've got 9 divided by 2 root 58, and then I want the inverse tangent of this, so I get 30.57 etc. degrees. So I have 30.6 degrees given to 1 decimal place. Question number 19. We have to show that 3x over x plus 2 subtract 2x plus 1 over x minus 2 minus 1 can be written in the form ax plus b over x squared minus 4. Well, what we have is x plus 2 and x minus 2, and 1 as our denominators. So what we can do is write everything over a common denominator. I've got this 3x, and if I have x minus 2, then on the bottom I need x plus 2 times x minus 2. The x minus 2 simplify to 1, leaving us with 3x over x plus 2. And then we subtract 2x plus 1 over x minus 2. Well, if I've got the 2x plus 1, then what I need is an x plus 2 on the top and an x plus 2 on the bottom. Those simplify to 1. And if I've got this x minus 2, then we would have 2x plus 1 over x minus 2. And Then we are subtracting 1, and 1 is the same as x plus 2 times x minus 2. So let's try to tidy all of this up. If we attempt to tidy all of this up, then on the top we've got 3x times x minus 2 minus 2x plus 1 times x plus 2 minus x plus 2 times x minus 2. And on the bottom, I've got x plus 2 times x minus 2. So now let's try to simplify the top. I've got 3x squared minus 6x minus, and then in brackets here, we would have 2x squared. Then I've got 4x plus another x, so that's 5x. Plus the 2, subtract, and then here if I expand and simplify, we've got x squared minus 4. And on the bottom, we've got x plus 2 multiplied by x minus 2. So what we will do now is we will simplify all of the top by multiplying the negatives into the bracket. So I've got 3x squared minus 6x minus 2x squared minus 5x minus 2 minus x squared plus 4. And on the bottom, I've got a difference of 2 squares, so I've got x squared minus 4 on the bottom. So let's simplify all this. Well, 3x squared minus 2x squared minus an x squared, that's 0x squared, minus 6x minus 5x, that's minus 11x. And then I've got the minus 2 plus the 4, so that is plus 2. And on the bottom, we have x squared minus 4. So we've written this in the correct required form. And that's exactly what we wanted to show. Question number 20. The profit made by a shop increases each year. The profit made by the shop in year N is P in pounds. Given that the profit made by the shop in the next year is Pn plus £1, then Pn plus 1 is equal to A times Pn plus 800, where A is a constant. And what we have to do is, well, we're given that this table which shows the profit made by the shop in 2018 and 2019, and we have to work out the profit predicted to be made in the shop in the year 2021. So in 2018, the profit 24,000. In 2019, the profit is 29,600. So with this, we can find out what A is. The profit in 2018, that's equal to £24,000. And the profit made in 2019, that's A times by the profit made in 2018, the previous year, plus 800. So the profit made in 2019 is 29,600, and that's equal to A times the profit made in 2018, which is 24,000, plus 800. And with this we can find out what A is. A then, that's equal to, well here I would have A equaling 1.2. So we can therefore conclude Pn plus 1 equals 1.2 times Pn plus 800. We'll be working with this formula. So what we can do is find out the profit in 2020 and then 2021. So the profit in 2020, that's equal to 1.2 times P 2019 plus 800. So if we work this out, I've got 1.2 multiplied by the profit in 2019, which is 29,600 plus 800. So let's work this out. Well, if I type in 29,600 and then 1.2 times this plus 800, it turns out the profit in 2020 is equal to 36,320. And the profit in 2021 then, I've got 1.2 times the profit in 2020 plus 800. So I've got 1.2 times by the profit in 2020, 36,320 plus 800. And it turns out we have 44,384. So that is the profit. We have 44,384. Question number 21. Ray has 9 cards numbered 1 to 9. So we've got 1, 2, 3 all the way up to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and then records the result. We have to work out the probability that the result is an even number. So what we have to do in this question is think about how many ways we could get an even number. So let's write down those possible outcomes. So here I could have an odd number plus another odd number, that gives an even, plus another even, that's going to give an even number. I could have an odd number plus an even number, that's odd, plus another odd number, that's even. I could have an even number, an odd number, and another odd number, that gives an even number. And if I have an even plus another even, plus another even, that gives an even number. So we need to work out the probability of these. So let's consider the first one. The probability of selecting an odd. Well, how many? Well, I've got 9 numbers in total. How many of them are odd? I've got 1, 2, 3, 4, 5 of them which are odd. Now there's going to be 8 numbers left over. How many of them are going to be odd? Well, that's going to be 4 because I've already selected one of those odd numbers. And then, if I select another one, there's going to be 7 numbers left over. And how many of them are going to be even? Well, I've got 1, 2, 3, 4 which are even. And timesing these, that will tell me one of the ways I could get an even number. So 5 times 4 times 4, that's 80. 8 times 7 times 9, that's going to be 504. Now let's consider odd, even, odd. So here, same idea. I've got 9 numbers in total. How many of them are odd? Well, 5. Then I've got 8 numbers left, and how many of them are going to be even? Well, there's going to be 4 even numbers left. And then to select another odd, well, there's 7 left. I've already selected one of them, so that's going to be 4, because I've already selected an odd. And again, we get 80 out of 504. Now let's think about even, odd, even. So even. Well, I've got 9 outcomes in total. How many of them are even? That's going to be 4 of them. Now for odd, I've got 5 odd numbers, 8 are left over, and if I want another odd, well, 7 are left and there's already 1 being selected, so 4 remains. So it turns out here I get 80 out of 504. Now let's think about selecting 3 evens. So if there's 9 numbers in total, how many of them are even? 4 of them. Now I've already selected 1 even, so how many is going to be left over? That's going to be 3. And if I've already selected 2 of them evens, 2 of them are going to be left over. So what I get over here then is 24 out of 504. And so therefore, for the probability of getting an even number that will equal, well, what we have is 80 out of 504 plus 80 out of 504 plus another 80 out of 504 plus 24 out of 504. So if I work this out, I get 264 out of 504. And if I work out what this is, it turns out I get 11 over 21. So probability of selecting an even number is 11 out of 21. Question number 22. L is a straight line with equation y equals 2x minus 5. C is a graph with equation y squared equals 6x squared minus 25x minus 8. Using algebra, we have to find the coordinates of the points of intersection of L and C. You must show you're working. Well, I've got y equals 2x minus 5, and I am solving this simultaneously with y squared equals 6x squared minus 25x minus 8. And I can replace the y here, so I have 2x minus 5 squared. So I've got 2x minus 5 squared equals 6x squared minus 25x minus 8. So 2x minus 5 all squared, that's going to be 4x squared minus 20x plus 25. And that's equal to 6x squared minus 25x minus 8. Take everything over to one side. I have 2x squared minus 5x minus 33 equals 0. And if I factorise, I have 2x minus 11 multiplied by x plus 3 equals 0. Which means, if 2x minus 11 is 0, x is 5.5, and if x plus 3 is 0, x is minus 3. So we can now find out the corresponding y values. So y will equal 2 multiplied by 5.5, and then I've got the minus 5. So it turns out here we get 6, and we also have y equals 2 times by minus 3 minus the 5, so that's minus 6 minus 5, that's minus 11. So what are the coordinates of the points of intersection? I've got 5.5 and 6, so that's one coordinate. And for the other coordinate, I've got minus 3 and minus 11. So these are the coordinates of the points of intersection.